Example 1.5, determine the constant G so that the power absorbed equals the power delivered for the circuit shown. So we have to use conservation of power to determine the gain G. Let's focus on where G is at. So let's focus where G is at. And you can see that it's in the middle element. So I have a dependent source. So this is G I of X, and you could see that the current flowing in this branch here is 2 amps. So when I look at the power of GIX, it has to be the voltage GIX times the current 2, so it's going to be 2GIX. And you can see here, according to the current convention, this tells me that it's an active element or an active source. That being said here, let's go start to look at this. So I'm going to use conservation of energy / power to determine G. So the first thing I got to do here is I have to identify which elements are active versus passive. So let's go look at that. So I'm gonna put in my circuit here, and I'm just gonna be real clear about what the current is. So let's follow the first loop on the left. So you could see here is that tells me that I have 2 amps coming in here, and therefore 2 amps are coming in there. Now, if I look at this one here, I'm looking at the 4. You can see here is that this 4 is going in that direction. So I now know that IX is equal to 4 amps. And then finally, we've already identified this, but we said that this guy right here has to be 2 amps. So going through this here, now I can identify what is passive or active. So here I go. So the active elements are the ones that have the current entering the negative terminal. So right away, I could see here on the left loop that element A has to be active. Element 2, so let me come over here and say passive right here. When I get to the 2 volt, you could see here is that guy has to be passive since the current enters the positive terminal. Now, if I look at my dependent source, you could see that this guy, we've already said, was going to be active. And then if I look at B, you could see that B has to be passive. So now I can equate these guys. So if I look at A, it's going to be 14 times 2. Then this guy here, we've already written down, that's going to be 2GIX. But we already identified that IX is 4. So therefore, this has to be 28 plus 8G. Now, if I look at the passive elements, then I see here is that the 2 volt is going to give me 2 times 2. And then the passive B here has to be 4 times 12. So that's 4 times 12. And that's going to give me a value of 48 plus 4, which would be 52. These are all in units of watts. So setting these equal, we then see that P active must equal P passive. So this has 28 plus 8G has to equal 52. So if I now solve for G, I find that G is then going to be 3 volts per amp.